they involve your application of factorization, then law 1 of exponents. Okay, you also need to know your prime numbers, because you might need to change some of the bases to prime bases. Okay, so before I go anywhere here, I'm going to break this up based on law 1 moving from right hand side towards the left hand side. Remember, I told you that if you are given a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So we are moving from the right hand side towards the left hand side of the first law. So here, sometimes it's not necessary to convert a specific number to a prime base. Like in this case here, the 4, I can just write it as is. Okay, that would be times 3 to the power of 2x times 3 squared minus 3 to the power of x times 3 to the power of minus 1. Okay, instead of breaking it up, let me use law 1. You see that the base is the same there. Do you see that? We have the same base and we are multiplying the bases, so we can add the what? The exponents using the first law. So x plus x, that will give me what? 2x minus 1 plus positive 1, that will give me a 0. Are you following that? Yes. I have used law 1 here because I'm multiplying two bases that are the same. I did that so that I can simplify that exponential term. It's a product of two exponential terms, but I can combine it into one. All right? Then, the denominator, since here we have got a 9, 9 can be written as what? 3 squared. So if I write it as 3 squared, that would be times 3 to the power of 2x minus 2. Okay, at this stage here, because of this 3 squared, I need to apply law 1 so that I can simplify that denominator. Then from there, I'll have 4 times 3 to the power of 2x times 3 squared minus 3 to the power of 2x. This is all over. Now I can add these two exponents. One is binomial, the other one is a monomial. So 2 plus minus 2, that will give me what? 0. So I'm left with 3 to the power of what? 2x. So I have simplified it so that I can be able to identify the common factor. Then from here now, in the numerator, what's our common factor? It's 3 to the power of what? 2x. Then I'll open my bracket, that will be 4 times 3 squared minus 1. This is all over 3 to the power of 2x. Okay, so these two can just cancel out there because they are the same. One is in the numerator, the other one is in the denominator. So 4 times 3 squared, that will give us 36 minus 1. So your final answer will be the 35. Okay. So if you did the question, you mark your way, you put a tick every step. Okay, a question like this may be 3 marks or maybe 4 marks. Okay. Any question? So this was straightforward. Right? The next question. Now this question here, I'm going to show you two methods because of the nature of this class. I'm going to show you two methods of doing this question. Okay, you can then decide whether you prefer the first method or the second method. So, remember yesterday I told that if you're given an exponential term like this, 2 to the power of 2x is the same as 2 squared all raised to the power of x. It's also the same as 2 to the power of x all squared. Remember that yesterday if you're paying attention. Right? So we are going to apply that, but we are going to need this form here in order for us to be able to do this question. So I can rewrite that 2 to the power of 2x is 2 to the power of x all squared minus 9 all over 2 to the power of x plus 3. Okay? All right? Now let's say this is method 1, the one that I'm going to use now. It's method 1. How many of you agree with me that this whole term here, it's a perfect square? How many of you understand that it's a perfect square? Please raise your hand if you understand that it's a perfect square. Some of you, your hands are being raised with a bit of some doubt. Okay. All right. I hope you all know that if you have 4, for example, 4, this is the same as 2 squared, isn't it? Which means this 4 here is a perfect square. You can also say this 2 squared is a perfect what? Square. Okay, so since the exponent is a 2 there, that tells you that the term is a perfect square. So here, our term is 2 to the power of x, but it is squared. Therefore, the whole term 2 to the power of x all squared, it's a perfect square. Then we have a minus here. Is 9 a perfect square? Yes. Then we go back to grade 9 and 10. Remember, you did dots. Difference of what? 2 squares. 2 squares. You remember that? Dots. So in grade 9 and 10, we were told that if you've got a term like x minus y squared, when you factorize it, you get x plus y times x minus y. Isn't that so? Yeah, so that knowledge of dots from grade 9 and grade 10, when you are in grade 11, you are doing exponents. It is required. That's why you did it in what? 9 and 10, to prepare you for this year. So all the concepts on factorization that you were taught in grade 9, grade 10, you need them this year, especially this term. Right? So this will be equal to. Now, if I apply that in terms of dots to this expression, which is our numerator, my 2 factors will be 2 to the power of x minus 3 times 2 to the power of x plus 3. This is all over 2 to the power of x plus 3. Are you following that? All right. Now I'm sure you can see that this 2 to the power of x plus 3 and that 2 to the power of x plus 3, they are the same, so they cancel out. So our final answer will be 2 to the power of x minus 3. Please be aware that this 3 here is not an exponent. So when you write, be very careful. It's not an exponent, it's an integer. Okay? It stands on its own, it's not an exponent. And this x here is not multiplying the 2, but it is an exponent of the 2. So there has to be a distinction there when you write it down. Okay, so this is method 1. So if you want, you can just write here method 1 in your book. So that's method 1. Then let's move on to method 2. Okay? Method 2 so we have 2 to the power of 2x minus 9 over 2 to the power of x minus, okay, it's a plus 3. Okay, obviously the first step is to rewrite that term as 2 to the power of x all squared minus 9 all over 2 to the power of x plus 3. Alright? Okay, I want you to pay attention carefully. Then we can use what's called the K method, whereby we move away from exponents to your normal algebra, which you were taught from grade 9. Okay? So I can replace this 2 to the power of x by any other letter except x on the English alphabet. Okay? Generally in maths we use K, but you can use another letter. Okay, so I'm going to use k so that you start getting used to the k method. So I'll say let k be equal to 2 to the power of x. Okay, the reason why I'm introducing the k method for method 2, because some of you have issues trying to factorize that exponential term, or rather to factorize this numerator here. Okay, because you are not used to working with factorization of exponential terms. So it's better we take you to what you are used to from grade 9 and grade 10. Once I do this, it means where there is 2 to the power of x, I'll put what? K there. So what this means is that you can say, therefore, we end up having k squared minus 9 over k plus 3. Now, we are in grade 9. We are in grade 9. Once we write this expression here, this expression, we are in grade 9. Okay? And I'm sure you are familiar with this. This is more familiar to you. So, this will be equal to k minus 3 times k plus 3. This is all over k plus 3. So fortunately, these terms can cancel out in terms of k. So that the answer in terms of k will be k minus 3. But our final answer must be in terms of x. Therefore, we replace this k by 2 to the power of x. And then you get the same result. Okay. So that's the k method. The k method is actually a way of solving some very complex mathematics problems. Okay, so we are going to use it quite a lot. Right, are you following? Huh? Is it making sense? All right, so let's move on to the third one. Okay. So here, my suggestion is convert all the bases to prime bases. That's what I would suggest before you start doing anything. So we have 3 squared times 2 to the power of 2x. Okay, I hope you understand where this 2x comes from. If I convert the 4 to 2 squared, then multiply the exponent 2 by x. Then minus, that will be 3 to the power of 2x plus 2. Okay, all over, this is 3 to the power of x plus 1. Well, at this stage, I'm not going to rush to break that up. So that will be 3 times 2 to the power of x. Right? So I've converted all bases to prime. Then the next thing now is for me to simplify all terms that look like the right-hand side of the first law, so that I can be able to identify my common factor. Okay? So we have 3 to the power of 2 times 2 to the power of 2x minus 3 to the power of 2x times 3 squared. This is all over. Are you following there? It's all over 3 to the power of x and 3 to the power of 1 minus 3 times 2 to the power of x. Okay? Now, if I were to ask you, so far as I'm concerned, do we have a common factor up to this point? What I mean is, do we have a common factor in the numerator that can be similar to a common factor in the denominator? Huh? What is that common factor? It's what? It's 3. Or we can say 3 to the power of what? Of 1. Do you all see that? We have this 3 squared here. We have that 3 squared. In our denominator, we have got this 3 to the power of 1. We also have that 3 to the power of 1. Which means if I want to take out a common factor after this step here, my common factor has to be 3 to the power of what? Of 1. Are you understanding that? Okay, so let's take out that common factor. So we have 3 to the power of 1. When we open the bracket, that will be 3 to the power of 1 times 3 to the power of 2x minus 3 to the power of 2x times 3 to the power of 1. This is all over. In actual fact, if you look at it carefully, okay, sorry, this is supposed to be a 2. So let me change that. Okay, this is a 2. That's a 2. Right, so our denominator, I can take out 3 to the power of 1. Then I'll have 3 to the power of x as my binomial factor, and 2 to the power of x as my second term of the binomial factor. Okay? Once I do that, it means these 2 can end up cancelling out. Okay? Those 2 can cancel out. Alright? Okay? Then, if I go further now, you see that I'll be left with another common factor, which will be 3 to the power of 1. So I'll end up having 2 to the power of 2x minus 3 to the power of 2x. This is all over. Now, since in my denominator, or rather in my numerator, I've got a binomial term which starts with 2 to the power of 2x, and there I've got 3 to the power of 2x, I can swap these 2. Okay? I can swap it. Alright? So, from there, I can write this as minus 3 to the power of 2x plus 2x plus 2 to the power of x. Plus 2 to the power of, yes, so that's 40. So this is minus 3 to the power of x plus 2 to the power of what? Of x. All I've done is I swapped the positions of these 2 terms. Because my numerator, no, it's supposed to be the other way around. Okay, it's supposed to be the other way around. Okay, my numerator, I've got 2 to the power of 2x, that's fine. 3 to the power of 2x, that's okay. So I need to swap those 2. So that will be minus 2 to the power of x, that will be plus 3 to the power of x. Are you following what I'm doing there? I swap the positions. Yes?
Why did you swap the positions?
Okay, the reason why is because I want to see if I can factorize this numerator binomial factor, and maybe one of its factors can cancel out with that denominator. Okay, it is very much possible. Okay, before I carry on, do you understand what I did from here, from this step to that step? Okay, let me just indicate it here. If you want to simplify from this step here, okay, I'm sure you can agree with me that our numerator, its binomial term, the first term, starts with a 2. Isn't that so? The base is 2. So it would be better to swap this minus 2 to the power of x and that 3 to the power of x. So that in the next step, I'll end up having this. I just swap their positions so that they look almost the same, like the binomial factor in the numerator. I just hope you can see that. That's by observation. Yes?
I have a question.
Yes.
In the last column, the bottom of the left, it's 3 to the power of x times 2 to the power of 1, blah, 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 blah. And then when you go to the next one, where that second 3 to the power of 1, bro.
Okay. All right. Okay. If I were to ask you, how many 3 to the power of 1s do you have here? Yeah, how many? How many 3 to the power of 1s do you have? 2. Right? Earlier we agreed, he said it. When I said, from this step here, which term is going to be our common factor in the numerator? And he said 3 to the power of what? Of 1. So what that means is you can break up 3 squared into 3 to the power of 1 times 3 to the power of what? Of 1. Then you take one of them as your common factor. So you'll be left with the other one, isn't it? So this 3 to the power of 1 here and that 3 to the power of 1, if I add the exponents, I'll get what? I'll get 3 squared. Do you see that?
Yes. I was asking about subtraction.
Here at the bottom. Okay, which part now?
Never mind.
You actually confuse me because see from here I wrote it as 3 to the power of 1. From here it became 3 to the power of x times 3 to the power of 1. Is there anything which is confusing? This step here. Okay, I took out a common factor. Can I have your attention? From this step here, I took out a common factor. What was that common factor? It's 3 to the power of what? 1. If you want to get the binomial factor inside the brackets, remember what I told you yesterday, how do you get it? You divide this by the common factor. What is 3 to the power of 2 divided by 3 to the power of 1? It's 3 to the power of 1. That's why I wrote 3 to the power of 1 here. Right? And then if you divide 2 to the power of 2x by 1, you still have this. Okay. From here, I took out the common factor. What's the common factor? 3 to the power of 1. So I took that 3 to the power of 1. Then inside the brackets, if you divide this term here by the common factor, you're left with 3 to the power of x. You also do the same, you divide this by the common factor, you're left with 2 to the power of x. Can you sit straight? Sit straight. Okay, are we all on the same page up to this point? Do you understand why I swapped the positions of these two terms? Do you understand why? The main reason is because I'm going to factorize the numerator, the binomial factor in the numerator, so that it's going to look like this denominator, so that I can be able to cancel out terms. Okay, let's get on. So the next step now, is for me to rewrite the binomial factor which is inside brackets as a difference of 2 squares. Remember I told you earlier that we can write 2 to the power of 2x as 2 to the power of x all squared. Do you remember that? Can you look and pay attention please? And we can also write 3 to the power of 2x is 3 to the power of x, all what? Squared. So, I can write, I'm going to introduce square bracket now. So this is the same as 2 to the power of x, all squared, minus 3 to the power of x, all squared, all over. Now, my denominator, I can factor out minus 1 in the denominator. Remember, you did factorization. If I give you a term like this, so an expression like, say, minus b, okay, let's say minus ab plus a. If I ask you to factorize this, What are the two possibilities? Two possible answers. Huh? You can factor out minus a, isn't it? So you can end up having minus a times b minus a. Am I right? Which is also the same as a times minus b plus what? Plus a. And this will give you a times a minus what? B. But for our question, all I have to do is, I want to convert this minus 2 to the power of x to a positive. And that positive 3 to the power of x to a what? A negative. So for me to do that, all I have to do is factor out minus 1, then I'll end up having minus 2 to the power of x times 3 to the power of x.
So for that example over there, isn't it supposed to be minus a times b minus 1?
Okay, that's minus 1. This is supposed to be minus 1. But don't worry about that. Okay? This is supposed to be a minus 1. Right? And this one also has to be a minus 1. Okay, that will be a 1. And this one will also be a 1. Okay. So, okay, please, I'm sorry for that. So here, I factored out minus 1. Are you following what I got there? Huh? Then, if I were to ask you now, if you were to factorize this expression, what would be the factors? Yes, it's a difference of what? 2 squares. So if you are to factorize it, the next step, allow me to go to the next page. Right, before I move on to the next page, are you all following up to that point? Because the bulk of you had an issue with this question. It's a little bit complex to what you are used to. So, we'll get 3 times 2 to the power of x minus 3 to the power of x times 2 to the power of x plus 3 to the power of x. This is all over minus, open bracket, 2 to the power of x minus 3 to the power of x. Okay, now you can start smiling. Okay, so this 2 to the power of x minus 3 to the power of x cancels with that. Okay, but we are going to be left with a minus 1 in the denominator, which means this 3 divided by the minus 1, our final answer will be minus 3 times 2 to the power of x plus 3 to the power of x. If you want to remove the brackets here, you can end up having minus 3 times 2 to the power of x plus, minus 3 times 3 to the power of x. Please, you cannot, okay, in this case here, it's not necessary to use law 1 to simplify this. It's not necessary. So you can leave your answer like that. But I would leave my answer like this. Okay? So this will be the final answer. But it can also be simplified and be left like that. The answer is not a real number. Okay? It's actually in terms of x. If x is real, then the answer is going to become a real number. But in this case, we don't know what x is. So your answer must be in terms of x. Right. Okay, I'll carry on tomorrow. So if you haven't finished, you need to carry on at home.